Students, this is the ALEKS help video for 2.1 through 2.5. Taking a look in your study guide. I'm going to skim through these problems. You are welcome to put this in double time and just slow down for the problems you need help with. Our goal is to graph the line here. So we are doing y equals mx plus b. Our b here is -5. So that's our y-intercept. And our slope is 1/5 positive. So I know our slope's going to go up from left to right. So you rise 1/5, 1, 2, 3, 4, 5, or you could drop 1 and go left, 2, 4, 5. To either way is to get yourself a positive line. This line is not yet in y equals mx plus b. So you want to get y by itself. I'm going to bring that 5x first so you recognize it as y equals mx plus b. And your b here is -4, so that's -4 on the y-axis. Slope is always a fraction, so even though that's a whole number, you must pop it over 1. So it's going to be rise 5/1. Says we want to find the slope of the line passing through -7 and 9 and -7 and -3. So we go here, slope is rise over run. Rise, you subtract the y's. I go y minus y. I like to use arrows to make sure I'm consistent in connecting with the numbers. Usually I circle the x's and box the y's. So that's going to be 9 and -3. And then here, run is going to be -7 and -7. Coming here, you can take a look. Double negative makes a positive. That is 12 over double negative makes a positive 0. You're like, what's that? Be very careful. That is going to be undefined. So let me get the summary here. All vertical lines are going to be a number over 0. And that is because there is no left or right motion. There's no run, which is in the denominator. All horizontal lines are going to be 0 over a number because they have no rise, no up or down motion. So 0 over any number is just 0. So a horizontal line is 0 slope. A number over 0 is going to be undefined. Said calculate the distance. Give the exact answer, which means you want a simplified radical, your distance equation. Giant square root. Subtract the x's squared, subtract the y's squared. So I circle my x's. I'm going to draw an arrow left to right. Box my y's. I draw an arrow left to right. Watch the double negatives. That's -8 plus 3. That's -5. 9 minus 3, that's 6 squared. Watch that radical sign. So I got square root of 61. And you see if you can factor it. And we know 2 doesn't go in there. 3 doesn't go in there. 5 doesn't go in there. 13 doesn't go in there. Okay, so it's actually prime. If it wasn't prime, you would pull out your dates. So your final answer here is going to be root 61. Says you have ST where this is a midpoint. Okay, so midpoint means middle. So there's M, here's S, here's T. S is at 0, 2. T is at unknown X and unknown Y, and our midpoint is 3, 4. By definition, the midpoint means middle. So that means this segment is of equal distance to this segment. So because they're equal distance, you also have equal distances between the X's and equal distances between the Y's. So going this way, on a number line, the distance between 0 and 3 is 3 units. So that means 3 going to this X must also be 3 units. Like, where is that? So if I start at 3 and I go bunny hop 3 units farther to the right, I'm going to be at 6. From 2 to 4 is 2 units. So from 4 to the next number must also be 2 units. So 4 plus 2 is also 6. If you were to graph this on a grid, which you could easily do, you could bunny hop this way, and from here to here would be 3 units, 1, 2, 3, up to 1, 2. And to get to this line, 3 units, 1, 2, 3, and up 2, and you'd be at the other endpoint to check it. In the figure below, S is between Q, T, and T. R is the midpoint of QS. RS is 7, QT is 17, find ST. It's really important. Do not immediately focus on what you're trying to find. Just kind of ignore it. And just mark everything you know to be true. Most important thing that's true here is R is a midpoint of QS. That means Q to R and R to S is exactly the same. We know that Q to T bracket colors are really helpful for these ones. And we know that R to S is 7. Now, instead of focusing on what you're told to focus on, just ask yourself, what can I find? Well, the midpoint here means they're equal. So that means this is 17, which means this is 14. And this is 17. Take away 14. That's going to be 3. Let's look at what we're trying to find. ST. Oh, we already found it. ST equals 3 units. In the figure below, measure angle WXZ is 72 degrees. Measure angle 2 is 3 times the measure of angle 1. Find measure angle 1. Whenever you compare one thing to the other, one thing to another unknown, the other is X. So right here, we're comparing angle 2, which is bigger than angle 1. I don't know angle 1, so I'm going to call angle 1 X, and angle 2 is 3 times X. So watch for these buzzwords. The word times is multiply. If you see the phrase more than, that's addition. You see the phrase less than, that's subtraction. So just watch out for that. We are told that the measure of angle WXZ, whole thing, is 72. So our thing equation is going to be the orange angle plus the yellow angle equals the larger red angle. Angle plus angle equals a larger angle. So circle plug check. X, 3x, 72. It'd be 18. 3 times 18. 54. Don't focus on the variables here. Let's get the big picture. We have two straight lines. Now there's two types of angle pairs here. First one, this is a linear pair. And linear pairs always add up to 180. These angles, straight across from each other, are vertical. Those angles are always congruent. So my thing equation is angle equals angle. So I'm going to solve here and do what I can. So right off the bat, I see my Z equals 93. So that one is easy, 93 degrees. Now I'm going to go for this one here. And so I'm going to have 93 plus 10x minus 63 equals 180. This case, x would equal 12. So share a spine, make a line, linear pair, share a spine, make a line, 180, vertical angles, congruent. Complete the proof and choose the reasons. So super important, you color code this. We are told that EG is equal to HI. So that's the big segments. Excuse me, HK. FG and HJ are also equal. So the big segments are equal, little segments are equal, and we're being asked to explain how is it true that E to F and J to K are equal. You just kind of think through logically. If the big segments are equal and the little segments are equal, and the little plus the medium segments add up to the big segments, if you take away the little segments, what's left, the medium segments are going to be equal. So what you heard is that segments add at some point and its segments take away at some point. Now, for this problem, you're going to have the steps on the left and you only need to come up with the reasons on the right. So right here, EG equals EF plus FG. The red plus the green equals the blue. Why is that true? In this case, it would be segment addition. HK equals HJ, which is the green, and JK, which is the red. And the red plus the green equals the blue. What is that called? It's called segment addition. We know that EG is equal to HK. Why is that true? Well, it's given. Now look very, 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 very carefully what's going on here. You ask yourself in step 4, what changed? Look very carefully. Here's EG. Here's EG. I swapped out EG and I put these two segments in. Here's HK. Here's HK. I swapped out HK and I put this sum in. So taking one thing out, putting something else in, that's called substitution. ALEKS used to require which lines. If they do, we used lines 1, 2, and 3. Taking a look here, why is this true? It's because it's given. Look very, very carefully. What changed between steps 4 and 5? I have EF, FG, HJ, JK. EF, FG, HJ, JK. You're like, whoops, this is what changed. You see? We swapped out a segment and we got HJ on both sides. We took one thing out and put something else in. That's going to be substitution. Last step is I can subtract. You can only subtract that which is exactly the same. And we get our targets, which we were trying to get to begin with. FG, HJ. That's called the subtraction property.